The United States Army is fighting on 2 continents and burning through submachine guns faster than its factories can replace them. The Thompson, the weapon American soldiers had carried since before the war, costs approximately $209 to manufacture. It requires 108 machined parts. It takes skilled labor and precision tooling that American industry is already stretched to provide. The Ordnance Department issues a demand: build a submachine gun that works just as well, costs a fraction of the price, and can be manufactured by workers who have never touched a firearm before. What George Hyde and Frederick Sampson deliver in response is a weapon so visually graceless that soldiers immediately nickname it the grease gun. It looks like something from a mechanic's toolbox. Its finish is rough. Its wire stock folds to a length that seems too short to be useful. It rattles when you shake it. Experienced soldiers who picked it up for the first time questioned whether it could possibly work. The reason this ugly American M3 grease gun outlasted every rival submachine gun had nothing to do with elegance and everything to do with what happened when it was actually fired in actual combat. Decade after decade, long after the Thompson was gone and the war it was built for was a generation in the past. This is the story of the weapon that looked disposable and refused to die. To understand why the M3 existed, you have to understand the specific crisis American small arms production was facing in late 1942. The M1928A1 Thompson submachine gun, the weapon American infantrymen, paratroopers, and NCOs carried as a matter of preference and prestige, was a manufacturing nightmare. Its production required extensive machining of high-quality steel components. The Savage Arms Company, one of its primary manufacturers, needed approximately 108 separate machined parts per weapon. At a production cost of roughly $209 per unit in 1942, against an M1 Garand rifle that cost approximately $85, the Thompson was consuming resources that a two-front war could not afford to sustain. The simplified M1 Thompson, introduced in 1942, reduced some of the machining requirements and brought costs down to approximately $70 per unit. But the Army Ordnance Department was looking at what the British and Germans had already discovered: that a submachine gun built from stamped sheet metal circuited components requiring minimal skilled labor could be produced at costs and speeds that traditional machining could not approach. The British Sten gun entering production in 1941 cost approximately $10 to manufacture and could be assembled by workers with minimal firearms training. The German MP40 had reached a similar industrial logic. Both weapons use steel stampings, simple welds, and minimal machined parts. Both worked. The performance gap between a Sten and a Thompson in close-quarters combat was far smaller than the cost gap suggested. The American Army needed its own stamped metal submachine gun, one that could be produced by the automotive and light manufacturing industries already retooled for war production. The question was not whether such a weapon was possible. The British had already proven it was. The question was whether American designers could produce one that met Army standards for reliability and performance, and do it fast enough to matter. In October 1942, the Army Ordnance Department formally initiated the development program that would produce the M3. The design contract went to George Hyde, a firearms designer who had previously worked on the M2H submachine gun, working in collaboration with Frederick Sampson, chief engineer at the General Motors Guide Lamp Division in Anderson, Indiana. Short pause. The choice of Guide Lamp Division was deliberate. Guide Lamp was an automotive parts manufacturer accustomed to high-volume stamped metal production. If the new submachine gun was going to be built on automotive manufacturing principles, it made sense to involve automotive engineers from the beginning. Hyde's design work moved quickly. A prototype was ready for evaluation in less than 3 months. The Ordnance Department tested the design at Aberdeen Proving Ground in December 1942, and despite initial concerns about the weapon's rough appearance and simple construction, the test results were sufficiently positive for the Army to authorize further development. The T-20 prototype, the designation given to Hyde's design during testing, was refined through early 1943 and standardized as the submachine gun, caliber .45 M3 in December 1943. The manufacturing cost was approximately $15 per unit, less than 1/10 the cost of the original Thompson M1928A1. The Guide Lamp Division produced the first M3s in 1943, and added triennial contracts were placed with the Buffalo Arms Corporation. Total M3 production reached approximately 622,000 units before the end of the war. A simplified variant, the M3A1, which eliminated the firing pin and bolt assembly charging handle in favor of a finger hole machined directly into the bolt, entered production in 1944 and further reduced manufacturing complexity. The M3A1 removed the manual safety entirely, relying instead on the open bolt design and a cover over the ejection port that blocked the bolt when closed. The weapon that had been designed in months would serve for decades. The M3 grease gun was designed around a philosophy that inverted almost every assumption of traditional small arms design, where conventional firearms design prized tight tolerances, polished components, and the kind of fit and finish that communicated quality and durability. The M3 was built on the opposite principle: loose tolerances, rough surfaces, and the minimum number of parts necessary to make the mechanism function reliably. This was not laziness. It was engineering judgment applied to a specific problem. Loose tolerances in a submachine gun firing pistol caliber ammunition in a TID blowback operating system mean that dirt, mud, sand, and carbon fouling have more room to accumulate before they interfere with the mechanism. A tightly fitted weapon can be disabled by contamination that a loosely fitted one shrugs off. The M3's designers understood that the weapon would be carried by soldiers who might not clean it for days at a time, in conditions that ranged from Pacific jungle humidity to European winter mud. Building in tolerance for contamination was not a compromise, it was the design. The stamped steel construction, the very thing that made the M3 look crude, was also the thing that made it fast to produce, easy to repair, and replaceable in the field without specialized tools. A damaged stamped component could be replaced from a supply of identical parts. A machined component required a machinist. The wire stock, which folded forward alongside the receiver, was another deliberate choice. A folded M3 was compact enough for vehicle crews, paratroopers, and tank commanders who needed a weapon that stored easily and deployed quickly. The stock looked flimsy. In practice, it was adequate for the close-range engagements the weapon was designed to dominate. The M3 was built to be used, not admired. That distinction drove every design decision. The M3 operated on a simple blowback principle, the same mechanism used in the Thompson and the Pater, Sten, with an open bolt that chambered and fired a round in a single rearward and forward cycle. The bolt itself was the dominant mechanical component. In the M3A1 variant, the bolt was machined with a recessed finger hole that allowed the shooter to retract it, manually eliminating the separate charging handle of the M3 and reducing the total parts count further. The bolt weighed approximately 12 ounces, and its mass was the primary mechanism controlling the cyclic rate. A heavier bolt means a slower rate of fire. The M3's designers chose a bolt weight that produced a cyclic rate of approximately 400 rounds per minute, deliberately slow by submachine gun standards. 400 rounds per minute is roughly half the rate of fire of the Thompson M1A1. This was intentional. A slower cyclic rate gave the shooter more control over burst length, reduced ammunition consumption per engagement, and made it easier for a soldier with limited training to fire accurate short bursts rather than emptying the magazine in a single uncontrolled pull. The magazine was a double-column, single-feed 30-round bow, TID-X feeding from below the receiver. The magazine was a known weak point. The lips that guided rounds into the chamber were vulnerable to damage, but this was a characteristic shared with virtually every submachine gun of the era, and the M3's magazine was no more fragile than the Thompson's. The .45 ACP cartridge, the same round used in the Thompson and the M1911 pistol, fired a 230-grain bullet at approximately 920 feet per second. At the close ranges for which the weapon was intended under 100 meters, in most combat applications, the .45 ACP delivered significant terminal effect. The slow, heavy bullet transferred energy efficiently to soft tissue in a way that higher velocity pistol rounds did not always match. The entire weapon, unloaded, weighed approximately 3.6 kilograms. With a loaded 30-round magazine, approximately 4.6 kilograms. It could be field stripped without tools in under a minute. That was the point. The M3's 400-round per minute cyclic rate translates directly into tactical capability that its critics underestimated. At 400 rounds per minute, a 3-round burst takes approximately 0.45 seconds. A trained shooter could deliver controlled 3-round burst, TDS, on a target at 50 meters consistently, with the slow cyclic rate providing enough time between rounds for recoil management. Against a target in a doorway, a trench, or a vehicle hatch, the environments where submachine guns were actually used, 3 rounds of .45, a CP, at close range was sufficient. The weapon did not need to be fast. It needed to be controllable. The effective range of the M3 was approximately 50 meters for accurate automatic fire, extending to around 100 meters for semi-deliberate aimed fire against stationary targets. This was not a deficiency, it accurately described where submachine gun engagements occurred. In building clearance, vehicle recovery operations, trench fighting, and the close-quarters combat of Pacific Island assaults, the weapon's range was adequate for every realistic scenario. The 30-round magazine provided approximately 4.5 seconds of continuous fire at the cyclic rate, enough for several fire-and-move sequences before requiring a reload. Reloading was straightforward. Magazine release, remove, insert new magazine. The single-feed design meant that magazines loaded slowly, inserting rounds one at a time into the double-stack body was timed. E-consuming, but this was a training and logistics issue, not a mechanical one. For tank crews, vehicle commanders, and soldiers whose primary weapon was too large to use inside or immediately around armored vehicles, the M3 provided a compact automatic weapon that could be stored in a vehicle and deployed instantly. That specific role would keep the M3 in service long after its original context had disappeared entirely. The M3 grease gun entered combat with American forces in the European and Pacific theaters in 1944. Issued initially to armored units, paratroopers, and infantry squads as a supplement and replacement for the Thompson. In the European theater, M3s saw service with armored infantry units attached to the armored divisions that drove across France following the Normandy breakout in the summer of 1944. The weapon's compact size made it practical for soldiers riding on or in vehicles it could be stored in a tank's hull without taking up the space that a Thompson or M1 carbine would require, and deployed quickly when a crew dismounted under fire. Armored vehicle crews who needed a personal weapon that was small enough to carry inside a tank but capable enough to defend against infantry at close range found the M3 well suited to their specific needs, in a way that larger weapons were not. In the Pacific, M3s were issued to Marine and Army units operating in the island campaigns. In the close jungle fighting that characterized engagements on Leyte, Luzon, and Okinawa, the submachine gun's range limitation was irrelevant. Engagements frequently occurred at distances measured in meters rather than hundreds of meters, and the .45 ACP's terminal performance at those ranges was effective against unarmored targets. The weapon performed as designed, reliably, with minimal maintenance, in conditions that degraded more precisely manufactured arms. After-action reports consistently noted that the M3 functioned under contamination levels that caused stoppages in tighter tolerance weapons. The loose manufacturing tolerances that had worried Ordnance Department inspectors in 1943 proved, in field conditions, to be a genuine operational advantage. The reason this ugly American M3 grease gun outlasted every rival submachine gun began to become clear, not in pause. Not in 1944, but in what happened after 1945, when the war ended and the Army began deciding what to DIP. The Thompson was retired. The M3 was not. In the Korean War from 1950 to 1953, M3A1s were issued to American armored units operating M4 Shermans, M26 Pershings, and M46 Pattons. The weapon's role as a vehicle crew arm was sufficiently established that no replacement had been procured. In Vietnam, M3A1s again appeared in the hands of armored vehicle crew soldiers, whose primary environment was inside an armored personnel carrier or tank, where a full-length rifle was impractical and a pistol was insufficient. By the 1980s, the M3A1 was still in the American Army's inventory as the standard personal weapon for armored vehicle crews. A weapon designed in 1942 to cost $15 and be used and discarded was still in active service 4 decades later, and the specific technical reasons for that longevity and the institutional decisions that sustained it are worth examining directly. Limits and weaknesses. The M3 grease gun's limitations were real, and soldiers who carried it knew exactly what they were. The magazine was the primary mechanical weak point. The 30-round box magazines feed lips. The metal lips at the top of the magazine that guided rounds into the chamber were acidly damaged if the magazine was dropped, stepped on, or handled roughly. A damaged feed lip caused stoppages that could not be cleared quickly in combat. The solution: carry extra magazines and treat them carefully was adequate in theory and imperfect in practice. Soldiers in the field subjected magazines to precisely the kind of abuse that damaged feed lips. Loading the magazine was also slow. The double-column body required inserting rounds individually against spring pressure that increased as the magazine filled. Loading a full 30-round magazine by hand took approximately 2 minutes for a practiced soldier. Speed loaders were available but not universally issued. In a sustained engagement requiring multiple magazine changes, this loading time was a genuine constraint. The weapon's accuracy beyond 50 meters was marginal for aimed fire. The short barrel 8 inches on the M3 and open sights provided limited precision at extended ranges. Against a specific point target at 100 meters, the M3 was adequate. Against a point target at 150 meters, it was not a reliable weapon. The wire stock, while compact, was uncomfortable for sustained shoulder fire. Extended use produced a weighted airiness in the shooting arm and shoulder that a conventional wooden stock did not generate at equivalent intensity. This was a minor issue in the short engagements the weapon was designed for, and a more meaningful one for soldiers who carried it as their primary arm over extended operations. These were the honest costs of the design philosophy. A weapon built for cheapness, simplicity, and contamination tolerance gave up precision, magazine robustness, and comfort. In the environments and roles where it was used, the trade was consistently judged worthwhile. Placed against its principal rivals, the M3's position in the submachine gun landscape is clear and more favorable than its appearance suggested. Against the Thompson M1A1, the simplified wartime version of the original design, the M3 was cheaper by approximately $55 per unit, lighter by approximately 0.5 kilograms unloaded, and more compact when the wire stock was folded. The Thompson's higher cyclic rate, approximately 700 rounds per minute, gave it a higher volume of fire, but reduced controllability. The Thompson's finish and construction communicated quality. The M3's did not. In head-to-head reliability testing under contaminated conditions, the M3's loose tolerances gave it an advantage the Thompson's tighter construction could not match. Against the British Sten Mark II, which had pioneered the low-cost stamped submachine gun concept, the M3 was more expensive but more reliable. The Sten's magazine fed from the side, creating a tendency for the weapon to be pulled off aim during firing that the M3's bottom-feeding design avoided. The Sten was simpler and cheaper. The M3 was more consistent. The German MP40, which represented the benchmark for military submachine gun design in 1942, was roughly comparable to the M3 in reliability and accuracy, but cost significantly more to produce than the M3 and required more machined components. The post-war comparison that mattered most was against the weapons that replaced submachine guns in the infantry role, the assault rifle family. Led by the Soviet AK-47 and the American M16, These weapons made the submachine gun obsolete for the infantry squad. But they did not replace the M3 in the vehicle crew role, because no compact automatic weapon was procured specifically for that purpose until the M3 was finally retired. The M3 outlasted every rival, not because it was superior in all respects, but because it was good enough for its specific role, and nothing better was procured to replace it. The M3A1 grease gun remained in the United States Army's inventory as the standard armored vehicle crew weapon until 1992, 50 years after its design. Its formal replacement was the M9 Beretta pistol, which became the standard sidearm for vehicle crews as part of the broader transition away from the M19 11.45, a CP pistol. Short pause, the M9 offered a higher magazine capacity and lighter weight, but gave up the M3 Prime, TID-S, automatic fire capability, and the terminal performance of the .45 ACP cartridge. Whether the trade was operationally sound was debated by vehicle crew communities for years afterward. The M3 also served with foreign military forces. The nationalist Chinese forces on Taiwan operated M3A1s for decades. Latin American militaries, including Argentina and Brazil, fielded M3s through the Cold War period. The weapon's simplicity made it easy to maintain in military organizations without sophisticated logistics infrastructure. George Hyde's design, produced in a matter of months in 1942 by an automotive parts manufacturer in Indiana, outlasted the Thompson, the Sten, the MP40, and every other submachine gun of its generation in American service. How soldiers remembered the M3 depended entirely on what they compared it to. Veterans who had carried both the Thompson and the M3 frequently expressed affection for the Thompson's feel and finish, and grudging respect for the M3's reliability. Vehicle crews who had carried the M3 as their only firearm tended to remember it more charitably, as a weapon that was there when they needed it and worked when conditions said it shouldn't. That is, it a specific kind of legacy, and it is an honest one. The M3 grease gun was never supposed to be permanent. It was designed to be cheap, fast to produce, and good enough for a war that planners assumed would end within a few years. It was built by an automotive parts company to be used and replaced, in the same way that wartime industry produced everything from Jeep fenders to artillery shells functional, expendable, and forgotten when the emergency passed. The reason this ugly American M3 grease gun outlasted every rival submachine gun is the same reason the most durable tools in any field outlast more impressive alternatives. It did exactly what it was built to do, without demanding conditions it couldn't meet, in the environments where it was actually needed. It was retired in 1992. By then, it had served in 4 conflicts across 5 decades. The weapon soldiers called ugly had outlasted everything built to replace it. If this kind of small arms history is what you come here for, subscribe. The weapons that looked disposable often had the longest stories. The M3 grease gun cost $15 to build and served for 50 years. That is the whole argument.